Located within the halls of Portland State University's engineering building, the student members of Viking Motorsports are working on their annual pursuit to develop a fully functional Formula-style race car to be taken to an international FSAE Collegiate Design Series competition at the end of the academic year. FSAE CDS, or Formula Society of Automotive Engineers Collegiate Design Series, is a world-class hands-on learning experience for undergraduate and graduate students.
My name's Tyler Reardon, and we are Capstone Group 13. And we're making the aero package for the VMS vehicle.
Our goal for the Capstone project this year is to design and validate a aerodynamics performance package for the vehicle, as well as provide adequate cooling to necessary electronic components.
Last term we were primarily in the design phase of things. There's very little hands-on manufacturing going on. I think there was a little bit of prototyping. We were trying to nail down how everything was going to be shaped, how things were going to look. And since then it's been full steam ahead with actually manufacturing and revising these designs based on what we can actually make, given our budget, given our time, given our tools.
It's been a lot more time consuming too than just the design was. I think we definitely have a lot of parts that we're trying to make.
You don't use it, you lose it.
So at the end of last term, we couldn't verify or validate that our shaping the floor of the underbody would create significant downforce, which means this term we've scrapped that idea, and now we're just making a very flat, simple floor, which is a little disappointing, but also it's going to make the car the fastest, so it's what must be done.
We did more fluid simulations and really determined that the only aerodynamic part that would give us performance increase was the rear wing.
So I've primarily been designing the mounting for the rear wing. We were initially looking at a top loading type thing, like a swan neck, and it was really fun learning topography optimization. But ultimately it wasn't going to comply with those FSAE rules, so we had to scrap that idea and went with a bottom side mounting system. And it'll be a little simpler, it'll keep the wing on, it'll be stable. It won't be as cool as Project Elf Hat Banana, but as long as the wing's on the car, then we're happy.
Been building a lot, spending a lot of time in the machine shop. Everyone's been working really hard to make composite material parts. So the floor, the nose cone, the body panels, and the rear wing too. All those are molds first, and then they get turned into fiberglass parts.
Well, it was really difficult at first when we thought our resin material, it was extremely toxic and kind of made the lab uninhabitable for a couple days. And so we had to figure out a way to relocate all of the layup processes off-site. So we kind of secured a workshop space with friends, relatives, and we were kind of having to commute to there for a while and do a lot of our work there. I have decided to put packing tape on them to not get all these fuzzies on them.
The van's aerodynamic package.
Yes.
So cutting freehand with a hot wire cutter, it is the quintessence of cutting butter with a hot knife. It doesn't track well at all, and while members of the team did an incredible job following pre-laid profile layouts, the post-processing and sanding that needed to be done to make everything even was determined to be too excessive. I really enjoyed using the hot wire cutter. This is probably one of my favorite parts of the manufacturing process. I like to do things as precise as possible, and the jig allowed us to do that. And it took some practice, but I think we eventually got it right. And I think the end result was really good.
What's that you're doing?
drill and foam.
The bulk of what we have been learning about here is these manufacturing processes and the most efficient way to build these things.
Part of our reasoning for moving towards an epoxy resin, which can be used safely inside in the VMS lab, which has very minimal ventilation, but it's where the car is being built. It allows us to be working with the team and communicating with the team in a way that we can constantly change and constantly iterate and improve our design.
Although it is a pretty simple process doing fiberglass layup, it is possible to do it poorly and have your layers delam on you. We're learning how tolerancing with these things is working out. These things like to bend and cure in their own kind of special shapes, which is very nice, and we love them for it, but we don't love them when it doesn't fit on the car like it did in SolidWorks. So we're learning, and we're overcoming these challenges by being creative and being a collaborative team that is working well with each other.
Do an engineering analysis on this.
I have actually finished the design and manufacturing, and as you can see here, the installation of the ducting subsystem. The goal with this accumulator ducting is we want passive airflow just to enter here based on the speed of the car. We need to meet a minimum of 1 meter per second air velocity across the accumulator. This design we verified with the CFD results is getting 1.97 meters per second. So it does exceed that, and so hopefully when in operation, this will provide the necessary cooling to keep the accumulator powering our drivetrain and not cause an electronic shutdown. And that's going to hold this ducting in place. We also have the other end here, which connects up to another 3D printed part. These are held into these welded tabs on the chassis, and that's what keeps everything fixed to our box here. And we will have an accumulator right here. These tabs here are going to be where the accumulator is set. This is going to butt up to the accumulator. We're going to have airflow coming externally from these fixed ducts here, and it's going to flow through.
The main concept behind this design was just creating a system that had heat dissipation after each heat generating component. This is the pump. That is what all the math was done to size and to purchase. That was the hardest part of the whole system. That was really the only part of the whole system. This is the motor controller. This is a heat generating component of the system. Here is one of the 2 radiators. That is a heat dissipation component. Here's the motor, our electric motor. Here's the second radiator. After the engineering analysis, we are flowing liquid at 2.6 gallons per minute, which comes out to like 9.5 liters per minute. Goal was to achieve a flow rate of in between 8 and 10 liters per minute. So we are within our desired range. I don't have anything final to say except for thank God it's over and thank God that it worked.
Looking back at it, after the results from like the fluid analysis were in, I think for a smaller team like Viking Motorsports, focusing on aerodynamic design is not as important as focusing on other major systems of the car. So I'm really glad that our capstone included the cooling components for the electronics, because those are really critical, and the data and analysis done this year will help the team in the future.
I think as the project wraps up, we're no longer doing things performatively. We're no longer counting minutes to satisfy requirements for a class. We're actually making a product. We're building something, and it needs to be done at a certain deadline, and we're taking it very seriously.
Working with the VMS team has been a treat. Those guys are fantastic. These are all collective goals that we all have, and it's awesome seeing everybody work towards the same thing.
Like I said, I haven't been able to spend as much time with the team as I would like to, but when I do get to work and stay for the long nights, it is fun to work with these people. So I'm glad this is a very positive experience, and I'm happy that I'm on this Capstone team.
So it has been a really satisfying process. And to see little incremental steps along the way lead up to something bigger, something that is 4 foot by 3 foot big. It's our rear wing is looking really great right now. So we'll get some paint on there and make it look good, and then test it out on the car. So having a track day where we can attach our wing and put it on and take it off and see if there's any improvement in lap time will seriously validate our project more so than any fluid simulations will. So right now the last steps are really focusing on finishing manufacturing and doing all the little detail work, which takes a long time to make sure all the lines are crisp and the bolts are tightened down and everything like that. We want to send a huge thank you to Sarah and Trisha at the department for supporting us this year and making sure our orders were in and helping us with logistical things, and they rock. They hold this place together, so thank you. We'd really like to thank Owens Corning Gresham plant for sponsoring our Viking Motorsports team this year, and also providing our Capstone Group with the foam material that we used to create our rear wing.
No, but this whole team's been great. Sarah, Trisha, you rock. Thank you. Braden, Gary, Ben, Owen, Hector, other people. Names are hard. You're all great. Thank you, VMS. Thank you. Go Vikings, yeah!